Namaste dear students. We have started chapter number 2, mechanical properties of fluids, and up to this we have seen 14 lectures. Today we start lecture number 15 and today's topic is terminal velocity. Dear students, listen video, listen this lecture up to end and read the topic carefully in the textbook and solve the questions which are given in the comment box so that you will study properly. This video lectures are only created for you and so you use this lectures properly. Do study at home. In this situation, these lectures will be only the way to study, and so you study at home. Also, share this lecture to your friends who don't know about the lectures, and also subscribe the lecture. So let us start the today's topic. And today's topic is terminal velocity. Now to study terminal velocity, let us consider a sphere of mass m and radius r, and this sphere is falling freely in the viscous liquid. Means this is a viscous liquid, just like oil. Means if you take oil and the sphere is kept in the oil, the sphere will move down or it will falling down. So consider a sphere of radius r and mass m, and it is falling down the viscous liquid. Now initially the velocity of the sphere will be smaller and it will go on increasing, and after some time the velocity will become constant. Now at some stage of the moving of the sphere in the liquid, suppose at this stage there are three forces acting on the sphere, and first force acting on the sphere is a viscous force. It is a viscous force and it is Fv. It is acting in upward direction. This viscous force is between metal sphere and the fluid. It is between the molecules of the metal sphere and fluid molecules. It is a viscous sphere. It is acting in upward direction. Then second force acting is the upthrust, or it is also called a buoyant force. Upthrust or buoyant force, it is denoted by Fu. So upthrust is due to the weight of the body which is in downward direction. It is due to the amount of the fluid which is displaced by the sphere. The sphere में जेवढे फ्लुइड डिस्प्लेस केलेलं असेल तेवढं फ्लुइड डिस्प्लेस केलेल्या फ्लुइड मुळे जो विरुद्ध जो फोर्स क्रिएट होतो तो म्हणजे अपथ्रस्ट फोर्स असतो. सो दिस इज द अपथ्रस्ट फोर्स और इट इज अ buoyant, it is denoted by Fu. Then third is a downward force, which is the weight. It is the weight of the sphere. It is also denoted by Mg. It is equal to W and it is Mg. So weight of the sphere, it is a downward force. It is acting in vertically downward direction. It is the force due to acceleration due to gravity, or it is also denoted by G. We also denote it by W and its value is Mg. Now as this sphere is falling, initially the speed of the sphere is 0 and the speed goes on increasing. and thus as speed goes on increasing, the value of Fv also increases. The value of Fv means it is the viscous force increases with the speed, and the net downward force acting on the sphere will be F is equal to Fg minus Fv plus Fu. This is the equation of the force in this situation, in which F is the net downward force and Fg is the force due to gravity. It is also weight, and minus Fv plus Fu, because this Fv and Fu are in upward direction, therefore they are negative. So this is the equation of force. As this sphere moves down, this Fv will be proportional to v, means as velocity increases, there will be increase of the viscous force. Here this Fu and Fg are constant forces. Force due to gravity, it is weight constant, and Fu, it is a thrust, it is also constant. And so this force will be means as velocity increases, there will be increase of the force. At certain stage, this force is equal to 0, means net downward force acting will be 0, and this net downward force acting is 0. At that time, Fg will be equal to Fv plus Fu, and V becomes constant, and this V is called the terminal velocity. So this is meaning of the terminal velocity. So this is terminal velocity. When downward force becomes 0, at that time Fg is equal to Fv plus Fu, and the velocity becomes constant, and that constant velocity is called terminal velocity. So this is the definition of the terminal velocity. Now let us find expression for terminal velocity. So we use this formula, which is upward force is equal to downward force is equal to upward force. We use this formula. Fg, it is a downward force, and Fv plus Fu, it is a upward force. We use this formula and say this is equation 1. Now what is Fg? Fg is equal to weight of the body, and it is equal to mg. Now what is m? M is mass of body, and mass is given by density rho multiplied by volume. This is formula of mass. Mass and density and velocity are related by m is equal to rho into v. Now the shape of the sphere, volume of the sphere is v, and it is given by v is equal to 4 upon 3 pi r cube. So 4 upon 3 pi r cube is the volume of the sphere. So mass of the sphere will become rho into 4 upon 3 pi r cube. Now put this value of m here. So Fg is equal to rho into 4 upon 3 pi r cube. So this is value of Fg. Say this is equation number 2. So multiplied by G. So it is G also equation 2. Now what is Fv? Fv is a viscous force. It is 6 pi eta r into V. It is given by using Stokes law. We have studied in lecture number 14. This is the Stokes law. Then find Fu. Fu is the upthrust. Upthrust means the force into the mass which is displaced by the sphere, and this force is also m into g, where m is the mass of the m is mass of the fluid. If we denote it by mf, suppose mf is mass of the fluid and multiplied by g. Now what is mf? mf is equal to density multiplied by volume, which is displaced by the liquid. So mf is mass of the fluid, sigma is density of the fluid, and v is the volume which is displaced. So this is equal to sigma into 4 upon 3 pi r cube. Same volume will be displaced by the liquid as the volume of the sphere, and so mf is equal to sigma into 4 upon 3 pi r cube. Now put this value of mf in this equation. So fu will be equal to sigma into 4 upon 3 pi r cube multiplied by g, and this is equation number 4. Now put values of equation 2, 3 and 4 in equation 1. So this equation 1, this is equation 1. So rho into 4 upon 3 pi r cube into g equal to 6 pi eta r into v plus sigma into 4 upon 3 pi r cube into g. Now here this pi will get cancelled on both sides, and we can write, let us simplify this equation to find v. So we can write 6 eta r v is equal to 4 upon 3 into 4 upon 3 into r cube, 4 upon 3 into r cube into g minus g, also it will be rho into 4 upon 3 r cube into g minus sigma 4 upon 3 r cube into g. Now take this 4 upon 3 r cube into g common, and in bracket rho minus sigma. So this is a 6 eta r into v. Now here this r will get cancelled, this will be square. So v is equal to, this 6 will become 3 and this will become 2. So v is equal to 2 upon 9 into r square into g rho minus sigma, and it is divided by eta, and this is expression for terminal velocity. This is the expression for terminal velocity. So from this you can find eta also. Eta is equal to 2 upon 9 r square in bracket rho minus sigma into g upon v. This is the expression for coefficient of viscosity. So eta is a coefficient of viscosity and v is a terminal velocity. So these are two expressions, expression for terminal velocity and expression for coefficient of viscosity. So all expression is on this board. You can also write this expression in the notebook from start to end. You will get full credit, you will get full marks in exam even if you write all these points in the question to find the expression for the terminal velocity, expression for coefficient of viscosity. So that's all here for today's lecture. We see problems in the next lecture. Thank you very much.